All right, so we got the biggest class we've had here yet, so let's hear this class.
Yes.
Thank you, I appreciate it, I do. All right, so I will apologize. I made a mistake. I forgot one thing when we were doing the fundamental theory of calculus yesterday. On this problem, it wasn't yesterday, it was Monday, right? On this problem, I forgot one thing. Because when we're plugging this in, it normally just goes in here, but we're taking the derivative, this right here, as this goes inside, and we're taking the derivative, this is going to be a chain rule. Because we have to have the derivative of this times the derivative of this. When we do that, it becomes a chain rule because this is not just x by itself. If this was just x by itself, then it would look like this problem right here. It would look like these problems right here. Okay, where we just plug it in and we get that answer. But because this is more than just x by itself, I forgot this. I apologize every time I do this. So I forgot the du. Because all this right here is, so my u in my chain rule would be 3x squared plus 1. My du would be 6x, right? So this is the problem that we did on Monday. I made a mistake. I forgot this part, this last little piece on here. So everything else was correct, but I forgot this last little thing, the du part. So because of this, as we put this in, so my answer is going to be e to the, let me back this up, because I'm not going to have enough room. 3x squared plus, come on brain, work, e 3x squared plus 1 plus 3x squared plus 1 times, because when I put this in, right, and it's going to be times du, right?
Yeah.
And my du in this case is going to be 6x. And that's what I forgot. So just that one little bit. So as I was going back over, I'm like, okay, I know something looks wrong here. So I went back and looked, I'm like, dang it. Okay, yes, there was something I forgot, and I forgot the du. Do you have the notes? This is
5.3.
5.3 and 5.4? No? Here's 5.4. Here's 5.3. There we go. Okay, so I apologize. I just totally forgot that. Okay, so now let's go ahead and try another one that's going to do the same thing. But for this one right here, if you notice, my x cubed is on the bottom. It's the lower bound. Yes? Okay, and so every time we do this, it's always going to be, when I take this, it's going to be like f of capital F x. So that's the integration. So if you notice, it's a capital F now. And this is going to be it's b minus a. Sorry, b minus integration a, like this. Because it's going to be, if this is my b and this is my a, it's going to look like this. So it's going to be from here to here. So one of the fundamental principles of calculus is that I could change the bounds. What do you think would happen if I change it from f of b minus f of a? What would I do if I change it to f of a and then f of b? What do you think I should do? If I rearrange these, if I switch those two, what do you think should happen? Negative. Very good. That's it.
Yeah.
I would just make it negative. So I could change the bounds of this. So that's what I'm going to do. I'm going to change the bounds because my fundamental theory of calculus, we're always plugging into this one here. So b minus a. But now, since this is actually set up like this, I'm going to reverse it. So now it's going to look like this. So it's going to be d dx, and it is going to be negative. That's going to be 5x cubed t to the fourth plus 1 to the 1/3 dt. So by flipping the bounds, I need to change the sign. And when we start looking at graphs, this will make a whole lot more sense too, of why and what. Yes, it will. Do you think it would make sense? No? Maybe? Possibly. Do you think I should just like make a graph and show you why it would make sense?
Yeah, the graph is on the homework, I think. Yeah, I remember how it looked.
So, if I did the sine, sine of x, and I take the integration of dx, so my graph is going to look like this. So I start with sine, and sine starts at 0. And that's a graph of sine, right? And that's taking it from 0 to pi. Integration means it's the area under the curve. So in this case, I'm taking the area of this, and I'm taking the area of this. But if I put this in the calculator, this is going to give me 0. Why do you think that's going to give me 0?
Because you're subtracting.
I am going to be subtracting, but what do you think is going to... This area right here is positive. This area down here is negative. Very good. That's why. We have a positive and we have a negative right here. So as we do this, when I'm adding these two together, it's going to give me 0. And so that's why when I flip things, it's going to be a negative. So if I were to flip this to change out what the area is right here, let's call this one's going to be pi, because that's where my
Intervals.
yeah, where my sine comes back to be 0, and right here this is all where my sine values are all negative. So after pi, okay, then 3 pi over 2 is right here, and this one's pi over 2, and right here is 2 pi. So that's why. So we have a positive, and then we have a negative. And so because that's positive, that's negative, when we add the two together, it's going to end up becoming... So we're going to have to change this up later on, but that's the whole reason why that it's going to be possible to change that. Because we are dealing with positive and negative values. All right, so fundamental theory of calculus. Fundamental theory of calculus. So now right here, because this is not just x by itself, I'm going to call that one what? U. Okay? That's going to be u because I'm plugging in something that's not just x by itself. So that's going to be u. So u is x cubed. So du is 3x squared.
Yep.
Okay. So, fundamental theory of calculus. So that means that I am now going to plug this in as is, and then I take the derivative of it. So that means that if I do the integration, the derivative and antiderivative at the same time, I'm going to be left with just what? Just plug this in, right? Okay, let's just plug that in. So, but now out here, that's going to be a negative. So it's a negative, and as I plug that in, what am I going to get? T to the what?
Wait, what?
I'm plugging in this. What's that going to give me?
3x8?
Nope.
No.
Here, let me rewrite it a little bit better. X cubed, right? I'm plugging in x cubed. I'm raising that to the 4th power. Right?
Okay, yeah.
So it's a power to a power. What does that mean I do?
Are you multiplying it? Or?
Yes, multiply. Multiply. Power to power, I multiply. So hopefully that makes it a little bit easier because my penmanship is horrible. So power to power, so that's going to be x to the 12 plus 1. I don't know why it keeps doing that to me. Okay, so plus 1, and then it's going to be to the 1/3 times what?
3x squared.
3x squared, my du. And the only thing I need to do to clean this up is actually put it out front with that negative. So I get a negative 3x squared x to the 12th plus 1, 1/3. All right, you guys feel pretty good about this? Hopefully.
Derivative, yeah. So it's just a bunch of chain rules again.
All right, here's what I was talking about with the fundamental theory. So let f be a function that's continuous on the interval from a to b if f, so they change it to a capital F now of a function that we take a derivative of. So it turns into a capital F, saying that we did take a integration of a lowercase f. And that's why it turns into this, and then it's b minus a, my top bound minus my lower bound. So in my interval from my second one minus my first one. Okay? So in words, so capital F, that was the integration, right? Prime. So with the tick mark, so f prime means the derivative, right? Okay, with the tick mark, that's the derivative. So what this is saying is, I took a derivative of the integration is just going to be the function. Okay, capital F is integration, where the tick mark means I'm doing the derivative of that. Yes, hopefully? Yeah, okay, so I'm putting a couple things together here. Then, from a to b, f of x, it's capital f of b minus f of a. If you can find an antiderivative of f, you can integrate f. So if there is a derivative, antiderivative, then you can integrate it. All right, let's see if we can find these here. So this is some of the stuff that we've already been doing. So the first one, I'm going to take the integration from -2 to 1, x squared. All right. So remember, integration. It's the opposite of a derivative. In the derivative, I take the exponent, I bring it out front, right? And then I subtract one from my exponent, right? Now we do it opposite. So think about that. So if I had to put the exponent out front and then subtract 1 from the exponent, what should I do first? Add 1 to the exponent, and then instead of bringing it out front, divide. So I'm going to divide by that new number. So I'm going to divide by that because a derivative, this would become 2x, but then the antiderivative, it goes the other way, so this is going to be x to the third over 3. Okay, add 1 to the exponent and then divide by the exponent. And my bounds say I'm going to take this from -2 to 1. So let's plug them in. So that's going to plug that in. So it's upper bound. So that's going to be 1/3 minus lower bound, -2 to the third power over 3. So doing the math, I'm going to get 1/3, and that's going to be plus 8 over 3. Add those together, I get 9 over 3, which is 3. Questions, concerns, complaints, conspiracy theories? Danny? You got this? Feel good about this? Yeah? So if I give you a test tomorrow on this, you'll say what? If you say bring it, right? If you got this, then you got it. Then bring the test, right? So, confidence. If you got it, then yes, bring the test. Bring the test. Yes? That's what I'm hoping for. B. So, from 0 to pi over 6, cosine dx. You guys remember this?
Oh yeah, the circle. Yeah, the whole circle.
Okay. So let's pretend like I know that derivative and then antiderivative, it just goes the other way, right?
Yeah.
So antiderivative, so the integration So the integration of this would go this way. So integration goes this way now. So what is the integration of cosine or antiderivative of cosine?
Oh, sine.
Yeah, it's sine. So this is going to give me sine x from 0 pi over 6 Now, what is sine at pi over 6?
Isn't, do you put in degrees or
No, it's radian. It's all radian.
Oh,
Pi
it's
pi
all
over 6
radian.
radian. Now, if you think about the circle, okay, it's in what quadrant?
First quadrant.
It's first quadrant, right?
It's on
Okay,
the-
so now imagine, is this before or after pi over 4?
Before.
It's before pi over 4, right?
And-
So that means that the y value is up and down, isn't it?
Yeah.
So if it's before pi over 4, that means the y value is going to be smaller.
Mhm.
Okay, y value is going to be smaller. So one thing that you need to remember is that rad 3 over 2 is greater than 1/2.
Okay, that's fine.
Okay, so that means that sine, it's the x and the y, right?
Mhm.
So the y value is going to be less than pi over 4, so that means the y is going to be smaller, so that means it's going to be 1/2. And the x value is going to be greater. Yes, no, maybe?
You got me lost at the part where you said it's greater than 1/2, even though I'm still trying to comprehend it. Yeah, that's fine.
Pi over 4, right? Pi over 6. So when you imagine these, this is my y value, right? Which one's bigger? My x value or my y value?
X.
The x value is bigger, right? So in this case right here, my x value is bigger, so therefore I get rad 3 over 2 is my x value. My y value is 1/2.
Okay, so 3 over 2 is greater than 1/2. Okay.
That's why. And then if I were to go over here, this is,
Pi over 3?
yep, pi over 3. So if I'm looking at it here, and this is my x value here, and then this is my y value, isn't it?
Yeah.
My y value is greater in that one, isn't it? So if the y value is greater, that means that the y value is rad 3 over 2. And the x value is?
1/2.
So hopefully good refresher.
Yeah.
And what's going to happen if I flip it over into quadrant 2?
The signs would switch. Well, no, you would also swap the.
Right here. So this is 5 pi over 6. Is the y value still positive?
Yeah.
Y value still up, right? But the x value is now negative, isn't it? That's why. So quadrant 2. So the numbers stay the same, but the signs will change depending on the quadrant. All right, so here we go again. All right, so sine at pi over 6 we said was
1/2.
minus sine at 0.
0. Yeah, it's 1/2.
C, 0 to rad 3 over 2. And this one right here is kind of a pain. But hopefully we do remember what this one is.
That's 0.
One minus x squared. So this should look somewhat familiar because we actually did derivatives where it gave me this answer. So I will pass out, I don't have them here yet, but I do have made copies of it, but I just
What is
did not pick them up yet.
it like a piece of paper?
Yeah, it's a cheat sheet.
Ugh.
Ugh.
Which one is that? Does it look like this one? Or is it different?
It's different.
Okay.
So it's this one right here.
Oh yeah, this one's for trigonometry.
Mm-hmm. It is. And so this is one of them. So it is going to be one of the arc. Remember when we did arc sine, arc cosine, arctangent? And it gave us an answer like this? So that's where the refresher should come in, when we did arcs. I actually have some here. Again, like I said, I will pass these out because it's been a hot minute since we did this. So this one actually is going to be an arc because it's going to be 1 over the square root of 1 minus x squared. So that's just going to be arc sine. Now, you guys recall what arc does?
It was like the inverse.
So let's go back to our circle right here. So it's arc sine, and it says rad 3 over 2, doesn't it? So that means I go to rad 3 over 2, and what I'm looking for is the angle that it gave me. So normally, I give you the angle, and you tell me the value. But now, arc is the inverse of it, so I'm taking the value and finding the angle.
So 60 degrees?
No, only radians.
Oh, in radians.
Only radians, so pi over 3. So, top is going to be pi over 3 minus, okay, sine 0 is going to be 0. Because on my unit circle it's 0.
Oh, so you have cosine 0? I was like, oh, no.
Yeah, cosine would be 1, right?
It would be 1.
So, like I said, I did not pick up those yet, but I will, and we could use those as reference sheets on your next test too. Make sense?
Yeah.
Okay, good. And what was this one? C? Yeah.
Yeah.
And last one is D. And that's going to be the last one for today. So from 1 to 2, 1 over x squared dx. Now, this is special. It is special. It is very special. And I'll show you why. This is going to be special because I'm going to rewrite this. I'm going to rewrite this here. So x to the negative 1 what do I normally do here? Okay, yeah, to do the antiderivative, right?
Yeah.
And so what do I do with my exponent?
You would add 1.
Add 1 and then
Divide by 1.
divide by the exponent, right? So if I add 1, that's going to give me
0.
x to the 0 divided by 0.
Black hole. Yeah.
It is not. This is a special thing in math where it comes up. So whenever you see just x by itself, 1 over x, the antiderivative of that should look somewhat familiar because we did do some of these when we did derivatives. We get, there we go, wait, right there. We get, this is going to give me ln of x. from 1 to 2. ln x. And yes, those are absolute value brackets. And if you do recall, we actually did take derivatives of ln x, which just gave me 1 over x, right? So these are hopefully just a bit of a refresher what we did the derivatives a while ago on those. So let's go ahead, top minus bottom, so it's going to be ln of 2 minus ln of 1. And since 2 is already positive and 1 is also positive, I don't have to worry about my absolute value brackets anymore. But what is ln 1? Anyone recall ln 1?
There's one. Oh, no.
0. ln 1 is going to be 0. Okay, so if you ever want to look at a graph to see what certain things are, there's like ln is going to be, so ln 1 is going to be 0. And then between 0 and 1, okay, is a whole bunch of negative numbers inside there, but it cannot go to 0. ln of 0 is undefined. So the properties of ln starts with right here. So the domain of ln would start at 0 and goes to infinity. So my domain for ln of x would go from there to there. So it cannot be 0. It could be after 0, to the right of 0, but it can't be 0. So that would be undefined. So I cannot have that one. But, and then from right here, ln 1 is going to give me 0. And ln 2 is just a number. So my answer is just going to be ln 2. Yes, no, maybe? Okay.
Yeah.
So, yes, I did cover a lot and have gone over, and hopefully you guys feeling a little bit better. So if I say that there's a quiz tomorrow over this, you're going to say what?
Bring it on.
Denny? Bring it? Don't bring it? All right, so make sure you guys all like, share, and subscribe. I want you guys working on the assignment.